All right, so let's pick up where we left off. Quite a bit done last time. Let's see where we're at here. All right. All right, so we're just solving for x. So for this one, you might be better off plugging in numbers than trying to solve for that. It's up to you. So go ahead and give it a minute or two, and then we'll talk about it. So what are we thinking here? Any ideas on this one? Okay, Mallory thinks it's B. Do you guys agree, disagree? What do you think? Okay, Mallory, did you plug in numbers or did you do the algebra? What route did you go on this one? Did the plug-in? Okay. All right, so that definitely works. So let's try Mallory's answer here. All right, so we're going to plug in 3 here for x. So 3 minus 2 is just 1. So we have 5/3 times 1, that's just 5/3, minus 1. Well, 1 could be rewritten as 3/3, right? Because anything over itself is just 1. And this is a useful thing when you're subtracting 1 in a situation where you have fractions. You can make anything a fraction just by putting it over itself. So as it turns out, 5/3 minus 3/3 is 2/3. So yeah, that works. Okay, so the algebra version of this, if you weren't sure how to do that, or you're having trouble plugging in numbers, dealing with the fractions and stuff like that, I know we don't like fractions. I'm with you. I don't like them either. Okay? So what we can do, let me clean this up a little bit. All right, so we don't like fractions. Well, both these fractions have a 3 on the bottom, right? So to get rid of the fraction, all you have to do is multiply everybody by 3. So this 3 cancels out. I just get a 5, right? Then I have x minus 2. And then 3 times -1, that's minus 3. And then over here, the 3's cancel out, and I get 2. Well, that looks like a lot easier to deal with, right? Okay, so we go ahead and distribute. There's 5x minus 10, and then minus 3 more equals 2. Put these guys together, I get 5x minus 13 equals 2. Get the 13 on the other side by adding them. Right, these guys cancel. So I get 5x equals 15. Divide both sides by 5. And you get x equals 3. Okay. So that's one good way to get rid of fractions. If you don't like dealing with fractions, multiply by something that will clear them out, which in this case was 3. Questions? Normally, I think plugging in is the easiest way to do that. Like I said, with the fractions, it gets a little dicey maybe. All right, so let's go ahead and check out another one. Okay, so it's solve the inequality. I'll let you guys take a minute and look at that, and then we'll talk. All right, we have a vote for C. What do you guys think? Agree, disagree? Let's hear from some other folks here. All right, we got a couple votes for A. All right, so let's check it out. So again, they give you stuff like this to kind of throw you off. Okay. And you just have to apply it to situations that you're already familiar with. So if I had, we're a little more used to equations and inequalities. So let's do this for right now. If I had y minus 5 equals 3, what would you do? For solving for y minus 5 equals 3, what do you do? Yeah, add the 5, right? So we do that. And then we get y equals 8. This isn't any different. So I've got minus 3 is less than y minus 5, which is less than positive 3. So again, we add 5, but since there's two parts to it, you're going to add a 5 here and a 5 here. Okay, so we do that. I get 2. And then these cancel out, so I just get the y in the middle. And then I get 8. So that's our guy. Savian, what I think you did was you ended up thinking this was multiplying by 5. And I think you multiplied both sides by the 5. It looks like what happened with your situation. Okay, so that one was really pretty easy. All they wanted you to do was add 5. Okay. Well, like I say, we get that stuff out of the way now, and that way it doesn't happen on the real test. Cool. Any questions? All right, let's move on. All right, so this one says we have a 20-foot piece of board cut into two pieces such that the second piece is 2 feet more than twice the first piece. So it says find the length of the longer piece of the board. Okay, so before we even get started, which answer is wrong? Which answer is automatically wrong? Think for a second. Which answer is not right? Well, I don't know about C, but how do you cut up a board that's 20 feet long and still have a board that's 20 feet long? Yeah, no. Yeah, I think Shelby's got the idea, so it's D. So D's out. All right, so go ahead and work on that one a little bit, and then we'll talk. So I think Liz is answering that it's C. She thinks it's C, and then we know D isn't right. But then again, they want to know the longer board here. So we got to kind of figure that out too. So I don't know if 6 is going to be the longest board. Okay, so you're saying C couldn't be it because it was short and you want the longer of the two boards? Okay, I can see that answer too. That's good. That's good. All right, so we're down to these two. So logically, you'd probably think it's the bigger of these two, right? So we're thinking maybe this guy. So we logic this out, and I think we probably got the right answer. Okay, but let's check it out. So if the second piece is 2 feet more than twice the first, okay, so that would be the first piece is x. The next piece is 2, so twice as big would be 2x, plus another 2 feet, and all that has to equal 20. Okay, so we put these two guys together, we get 3x plus 2 equals 20. Subtract off the 2, go up here. So that's going to give me 3x, these guys cancel, equals 18, so x equals 6. Okay, so this is where people get tricked. They get that and they say, oh, there's 6. I'm going to pick that for my answer. Wait a minute. The longer piece of the board. X is the short piece. Okay. So then that means we have to go back over here and say, okay, so 2 times 6 plus 2 is in fact 14. So even if you didn't go through it all, we could have logicked this out and probably figured out that, okay, well, it can't be 20, because if it's 20, we haven't cut anything off, right? Probably not 6, because that just seems like, you know, it's too small. And actually, you could do the same thing with 9, because think about it. This is less than half, right? This is less than half of 20. So it has to be twice as much plus some. So it has to be this guy. And this is something particularly on the PERT. You'll notice there's a lot of the questions that you can figure them out without having to do a bunch of work. This happens to be one of them. And there's quite a few questions like that on ACT and SAT as well, where you can kind of look at them, eyeball them, and say, yeah, that's got to be my answer, without getting all into it. All right, cool. Let's try another one. Okay, so this is just simplify. So take a minute and look at that. Fire an answer my way, and then we'll talk. All right, we got a couple votes for C. Let me show you a good strategy for these kind of problems. When they want you to simplify stuff, start by working with the numbers. What I mean by that is, let's look just strictly at the numbers, not the x's, just the numbers, okay? So if we do 4 times -3, that's -12. And -12 plus 17 is 5. So the reason I said work with the numbers, particularly in this case, look at this. If you did the part with the x's and you came up with 2x, you still have 2 answers to choose from, right? Or if you came up with -6x, you have 2 answers to choose from. But notice all these numbers are different. So if you figure out the answer for the number, you figure out the answer for the problem. Yeah, not bad, huh? And I mean, if you did the rest, then you get 8x minus 6x is 2x, so you're still going to get this guy. but you can save yourself a little time. And that's nice because, sometimes you have the more difficult problems. If you got a little more time to do them, you can get those right as well. In a time situation, of course. All right, cool. Let's check out another one. Ooh. So remember, reduce the fraction and subtract the exponents, and you'll get your guy. Go. All right, we got a lot of votes for D. So we know this guy isn't right because he didn't reduce the fraction. Okay. So basically we've got 14 and 35. We can divide both by 7. So that's going to give me 2 over 5. So that guy's gone. And then we just subtract the exponents, right? So we have m to the 6th minus m to the 1st is m to the 5th. This one says m to the 6th, so he's out. There's our boy. And then this guy here is you're going to leave, you got 5 up top, 8 on the bottom. That's going to leave you 3 on the bottom. So that's that guy as well. Okay, so that one wasn't bad. All right, next up. Can we factor this guy? So again, a possible strategy here is to multiply some of these guys back and see if you can get that. This is also done by something called factoring by grouping, if you remember that. But we'll talk about that here in a minute. I'm going to let you guys wrestle with it for a few, and then we'll talk. All right, Liz came up with C. So did you actually factor this thing, or did you just multiply stuff back together? Like I said, either one's fine. I'm just curious which way you went with it. You did factor? Cool. Okay. So let's talk about this. Usually, like 99 times out of 100 or more, this is a sucker bet right there. It's almost never that. Okay. So then this guy here, it says factor completely. Well, look here. We've got x's in here. We could factor out x's there. So he's out, right? Okay. So that leaves us two answers that look pretty similar except for the signs, right? So what I notice here is I've got xy, right? If I take 5 times xy, I get positive 5xy. And I've got negative xy, or negative 5xy. So I think this is my guy. All right, so let's go ahead and show you the factoring by grouping. And this is how Liz went about it. So we'll go ahead and rewrite this guy down here so we can do a little work with it. So factoring by grouping, what that means is typically you're going to have 4 terms. All right. And what you do is you take the first 2 terms and see what I can factor out of here. All right, so I've got an x and an x squared. That means I can factor out an x. And I've got y's in both, so I can factor out a y. Okay, so what do I have left? Well, x squared divided by x is just x. The y's cancel. Over here, the x and the y cancel. So I'm left with just minus 5. Okay? So then the next part, we look at this part. The only thing we can factor out of here is a 5, right? So let's go ahead and do that. So we factor out a 5, right? And then we get x minus 5. 5x divided by x is just x. 5x divided by 5 is just x. And negative 25 divided by 5 is minus 5. So notice these guys are the same. That's what we're going for. So when that happens, then we just collect these two guys together. So it would be xy plus 5. And then we only have to list this guy once. And then x minus 5. So that's our guy. So a couple different approaches there that you can take. But the bottom line with this test or any other kind of test like ACT and stuff like that is get her done. Or as we say in Florida, get her done, right? Questions on that one? All right, let's check out a couple more. We'll call it a day. Find the slope of the line. So to find the slope of the line, pretty much you want to solve for y. Whatever you end up with in front of x is your slope. Check it out. All right, we got some votes for B. So again, when we solve these guys for y, we don't even really have to worry about the 4. 4 doesn't really come into play at all. So if we solve for y, we move this guy over here, and he becomes minus 3x, right? Then I divide by the negative 2. So I got 3 over 2. The negatives, 2 negatives gives you a positive. So yeah, B. Good. Like I said, you don't have to worry about the 4 because it didn't ask you for the equation of the line in what they call a slope-intercept form. They just ask you for the slope, which is the number in front of x. So solve for y, the number in front of x is your boy. Easy and peasy. All right, next up. Okay, so this is another plug and chug one. So I'll go ahead and give you guys a minute to look at that, and we'll see what we come up with. All right, so we got a vote for A, we got a couple votes for B. So let's just plug the stuff in and see what happens. All right, so we're going to have 2. Instead of calling it x, we're going to call it minus 4. And then instead of calling it y, we're going to call it 5. Cool. And then we have minus 3. Instead of calling it x squared, we're going to call it minus 4 squared. And then finally just minus 11. All right, so step by step, 4 times 5 is, or 4 times, negative 4 times 5 is negative 20 times 4, or excuse me, times 2. That's going to be minus 40. All right, then here we've got minus 4 times minus 4 is going to be positive 16. 16 times 3 is minus 48. And then minus 11. So it's all negatives. So this guy's obviously wrong. So we have 40 and 48. That's going to give me 88. Minus 11 more, it's going to give me 99. So yeah, B looks good. All right, questions? All right, let's see if we can squeeze one more in and we'll call it. All right, it says find the standard form of an equation of a line with a slope of 3 passing through the point 2,4. Okay, so I'm going to give you a little help on this one. Standard form is so many x and so many y equals a number. Those are not even in the right form. So it has to be one of these guys. So at this point, what you can do, there's two things you can do. You can either figure out which one has a slope of 3, which was pretty much a problem we did a little while back, right? Or you can say, well, x equals -2, y equals 4. Plug those in and see which one is true. So you can go either way with that one. Okay. Savion's feeling D here. Did you plug in or did you figure out the slope? Or did you do all the algebra? Which I wouldn't recommend, but. You figure out the slope? Okay, cool. So yeah, if you moved him over here, then that would be -3x, and we don't have to solve for y because he's already just y. So -3 is your slope. Good. No, that was fine. Then the other thing you could have done was you could have said, okay, I've got 3 times -2, because that's x, and then plus 4, that's y. Does that equal -2? So 3 times -2 is -6, plus 4 definitely equals -2. So that would work as well. Okay? Good. All right, and on that happy note, I think we'll stop there for today. So again, I've already got attendance for you guys. I want to thank you for stopping by, and we'll see y'all next week.